Good morning, students. Now move to exercise 1.3, chapter number 1. This exercise is very important according to CBSE point of view. One question 3 marks must come from this exercise 1.3. Question number 1, exercise 1.3. Question number 1. Prove that root 5 is irrational. Prove that root 5 is irrational. Instead of root 5, root 2, root 3, 2 root 5, 5 root 2, root 7, it may be anything. Any number comes under root. The method to solve this type of question is same. Solution. Let us assume that root 5 is a rational number. So it can be written as root 5 equal to a by b, where a and b are integers, b is not equal to 0. Also, a and b are co-prime. Co-prime means a and b have no common factor between them other than 1. We can write a and b are co-prime, or a and b have no common factor other than 1. Both lines give the same meaning. This is first. Squaring both sides. 5 equal to a square upon b square, or 5b square equal to a square. B square equal to a square upon 5. From this we know that a 5 divide a square. Also 5 divides a. So 5 is a factor of a. Let a is equal to 5p. Put it in second. सबसे पहले हमने क्या किया, रूट 5 को a बाई बी के बराबर मानना. a और b क्या इंटीजर है, b 0 नहीं हो सकता, a और b को प्राइम है. स्क्वेयरिंग बोथ साइड 1 मीन root 5 equal to a by b. We get 5 is equal to a square by b square. 5b square is equal to a square, b square is equal to a square by 5. 5 divides a square, or a square is divisible by 5. 5 divides a. So 5 is a factor of a. Let a is equal to 5. We put it is in equation second. B square equal to, what is a? 5p whole square upon 5. B square equal to 25 p square upon 5. B square equal to 5p square, or p square is equal to b square by 5. Here b square divisible by 5, or 5 divides p square. Also 5 divides p. So 5 is a factor of 5 divides b square, and 5 divides b. 5 is a factor of b. From this, 5 is a factor of a and 5 is a factor of p. But we saying that a and b are co-prime. Therefore, 5 is a common factor of a and b. This, but a and b are co-prime. This contradiction arises because of our wrong assumption. Because of our wrong assumptions that root 5 is a rational number. Hence, so our supposition is wrong. Our assumption is wrong. So, or therefore, root 5 is a irrational number. Instead of root 5, if it becomes 2, if it becomes root 2, then the same method can be adopted to solve that question. That assume that root 2 is a rational number. Root 2 is equal to a by b, where a and b are integers and b is not equal to 0. Also a and b are co-prime. Squaring both sides, 2 is equal to a square by b square. 2b square is equal to a square. B square is equal to a square by 2. 2 divides a square. Also 2 divides a. So 2 is a factor of a. Let a is equal to 2p. Put it in second. B square is equal to 2p square by 2. B square is equal to 4 by 2 b square. B square is equal to 2p square. P square is equal to b square by 2. 2 divides b square, 2 divides b, 2 is a factor of b, 2 is a common factor of a and b, but a and b are co-prime. This contradiction because of a wrong assumption that root 3 is a rational number, so our assumption is wrong, hence root 2 is a irrational number. This is the complete solution. If it becomes root 2, root 3, root 7, anything, we can have the same method to solve this type of question. Move to question number 2. In question number 2, prove that 3 plus 2 root 5 is a irrational number. To prove this, first we have to prove root 5 is a irrational number, like we have proved here in question number 2. This complete solution of question number 1 we have to do in question number 2. After doing this complete solution, root 5 is a rational number, then we have to move, let 3 plus 2 root 5 is a rational number. So 3 plus 2 root 5 is equal to a by b. 2 root 5 equal to a by b minus 3. 2 root 5 equal to a minus 3b upon b. We have to take LCM of this. Root 5 equal to a minus 3b upon 2b. As we know, a, b, 2 and 3 are integers. So a minus 3b upon 2b is a rational number. Therefore, root 5 is a rational number. But root 5 is a irrational number. Proved above. Mean we have to prove first root 5 is a irrational number. Root 5 is a rational number proved above. Therefore, 3 plus 2 root 5 is a irrational number. You have to do this type of question like this. First we have to prove this a irrational number. This may be root 7, root 2, root 3, anything it may be. So we have to prove this, what it may be here, a rational number. Then we have to solve this in this way, and that is the complete solution. In some books it will be given only started from here and to this point, and this is incomplete solution of this type of question. Okay beta, move to question number 3. Prove that the following are irrational number. First part is 1 by root 2 and second part is 7 root 5 and third part is 6 plus root 2. This type is same 3 plus 2 root 5. So you have to do it yourself, and this type is also same like this root 5. You have to multiply it with 7 and the same statements you can apply in this question, and you have to find the solution of it yourself. Now we have to do this first part. Let 1 by root 2 is a rational number. We have followed the same step in every questions. So 1 by root 2 equal to a by b, where a and b are co-primes. A and b are co-primes and b is not equal to 0. Squaring both sides, 1 by 2 a square by b square, or b square by 2 equal to a square. 2 divides b square. 2 divides b. So 2 is a factor of b. Let b is equal to 2p. If b is equal to 2p, put it in this is first and this is second. Put b is equal to 2p in second, means b square upon 2 is equal to a square. Here we have to put the value of b. 2p upon 2p square upon 2 is equal to a square. We also put here, instead of this step we can write it also. This is 4p square upon 2 equal to a square. Cut it, becomes 2p square equal to a square, or p square is equal to a square by 2. 2 divide a square, 2 divides a, so 2 is a factor of a, hence 2 is a common factor of a and b. But a and b are co-prime, means they have common factor only one, but we find 2 is another common factor between A and B. So this contradiction arise because of our wrong assumption. Because of our wrong assumption that wrong assumption that 1 by root 2 is a rational number. Therefore 1 by root 2 is a irrational number. From these 3 solutions, you may find one solution in your CBSE exam for 3 marks. Very important exercise. You have got 3 marks if you have to adopt this method. Common steps in each and every question. Remaining part of this question you have to do yourself. Move to exercise 1.4. To understand 1.4, you have to first understand the basic. Means any number can be written as P by Q. P is numerator and Q is denominator. If Q contains its factor as 2 and 5, 2 and 5, or only 2 or only 5. If Q has factor 2 and 5, any both 2 and 5, or only 2 or 5, then P by Q is a terminating decimal. Otherwise मीन्स ना तो 2 है ना 5 है ना दोनों है, दोनों में से कोई भी नहीं है, ना 2 ना 5, कोई और नंबर है, देन P by Q is non terminating decimal. Now we have to solve question number 1. Question number 1. Without actually performing the long division, state whether the following rational number will have a terminating decimal expansion or non-terminating repeating decimal expansion. First part is 13 upon 3125. This is P by Q, and prime factor of this Q 3125. 5 6 जा, 5 2 जा, 5 5 जा, 5 1 जा, 5 2 जा, 5 5 जा. 5 2 जा 5 5 जा 5 5 जा और 5 1 जा mean factor of cube 3125 contains 5 into 5 into 5 1 2 3 4 5 5 into 5 mean it contains 5 as a factor, only 5. So P by Q is a terminating decimal. Second part, 17 by 8. 17 by 8 means 17 by 2 into 2 into 2 means denominator means Q contains 2 as a factor. So 17 by 8 is a terminating decimal expansion. So if a number with denominator or a denominator of a number having or any rational number, if its denominator having 2 as a factor or 5 as a factor or 2 or 5 both as a factor, no other factor comes with them, then they can be considered terminating decimal expansion. If any other number comes, part 8th 6 by 15, 6 by 5 into 3. Here 5 is a factor but 3 is also a factor of denominator. So this is, or 6 by 15 is a non-terminating decimal expansion. Now you understand how can we say a rational number a terminating decimal expansion and non-terminating decimal expansion. It can be depend on its denominator, a factor of denominator. And these questions comes in your CBSE exams for 1 marks only. Move to question number 2. Other parts you have to do it yourself. Write down the decimal expansion of those rational number in question number 1. So if we have to write first part 13 upon 3125, so we may write it as 5 into 5 into 5 into 5 into 5 because we already make its factorization here. We have to write it as terminating decimal expansion. But if we divide 13 with 3125, it's a very long process. But if we multiplied it 1, 2, 3, 4, 5, 2 into 2 into 2 into 2 into 2, and also divide it 2 into 2 into 2 into 2 into 2. 2 2 ja 4 2 ja 8 2 ja 16 ja 32, and when 32 multiplied with 13 it becomes in 32 multiplied with 13, 13 2 ja 26, 13 3 39, 39 plus 2 41 upon 5 2 ja 10, 5 2 ja 10, 5 2 ja 10 means 10 into 10 into 10 into 10 into 10. How many times 10? They becomes 1 2 3 4 5. So we have 4 1 6 1 2 3 4 or 5. This is the decimal expansion or terminating decimal expansion. We can write this 13 upon 3125 in decimal expansions. It's a very easy method to write it as, instead of dividing this by this. Similarly, second part, 17 upon 8, 17 upon 2 into 2 into 2. Again, if we divide this with 8, it's a long process, so we can multiply 5 into 5 into 5 upon and divide 5 into 5 into 5. 5 into 5 into 5, 125. 125 multiply by 17. 17 5s are 85. 17 2s are 38. 38 plus 8, 46. 17 and 17 plus 4, 21. Sorry, 17 5s are 17 to the 34. 34 plus 8, 42. Divide it with 10 into 10 into 10, and this becomes 17 by 8 equal to 1 2 3. So we have to point after 3. 5 2 1.2. If this is terminating decimal, we can express it in decimal form. But if it is non-terminating, then we cannot write it as decimal expansion. Okay, you have to do other parts yourself. Question number 3. The following real number have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factor of 2? First part, 4, 3.1, 2, 3, 4, 5, 6, 7, 8 or 9. 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Upon this point we have to take 1 and others we have to take 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the denominator of it, and we asked about the prime factor of q. So prime factor of q, factor of q, 10 raised to power 9 or 5 into 2 raised to power 9. So prime factor of q are 5 and 2. 5 and 2 and raised to power 9. So remaining part you have to do yourself. If this is terminating, so you can write it as this. If this is non-terminating, and non-repeating, like second part, 0.120, 1200, 120000, 120000 and so on. This is non-terminating and non-repeating. This is decimal expansion, but in So this cannot be right. It is irrational number. It is irrational number. So third part, 43.123456789 and bar 2129. So this is a non-terminating but repeating. Non-terminating but repeating. So it is a rational number. Is non-terminating. Non-terminating but repeating. Sorry, this is repeating. So it is a rational number. Rational number. So its Q is equal to, we have to write it in class 9th in the form of P by Q, and from where we find that Q is in form of 9. If this is 43.1, then it becomes Q is equal to 9. If 1 2, that 199. If this is 1 2 3 4 5 6 7 8 9, then we have to put 9 as much digits are there. These are 9s, so 9 nines are there. 1 2 3 4 5 6 7 8 or 9. So Q may be written in this form, and from this exercise you have to find only 1 marks question in UCBSE exam.